using VA Smalltalk. And well, Phaser Control is a system, is an integration platform for home automation protocols. So how to get all of the different systems under one hood, okay?
Yep.
Okay, so for example, if you have heating systems, heat pump system, normal oil boilers or something, if you have climate control for air conditioning, you know, lighting control, presence detection, multi-room audio video, well, all of your media stuff, light scenes and so on. And the whole theme is how to integrate the whole things. For example, if you have a contact on your window, this contact on the window may be used for security reasons, that you know if somebody opens the window. Also, if you leave a house, that you know which windows are open, which are not, which are closed. If you're present in a house and somebody opens the window, then you put the for example, the air conditioner or the heating in economy mode. It doesn't have to run full blown at that time. Also, if well, it's just about sharing all of the information that you have. One of the common things that we do is a presence detection in bathrooms. So if a person is in there, usually the circulation pump starts up, so warm water is available immediately at the faucets. You can make your light scenes that everything's comfortable in the bath. You can change the heating at the appropriate levels. You can turn on the multi-room audio so you have a little bit background music. Or if you come in the morning, you just hear your favorite news at that point. Okay. To start off, what I want to do is, usually you do demos at the end of presentations. I'm going to do it different. I'm going to do the demo right at the beginning of a presentation. So what I brought with me is an iPad. And this iPad has a little app from us, which is for our door communication. Yes, here's the picture. Jojo,
yeah.
Are you gonna help me a little bit? Okay. So this is live. Somebody would come up to the door right now and press the bell. That iPad would ring. You would see that person on the video, and and so that person you would see on the video, and you could talk to that person standing in front of you.
You have to press?
No.
Oh, you press.
Okay.
Now
What I'm going to do is our Phaser Control server at home also has a well, it's a SIP client, which I'm going to call now from here. That's going to interact with our Phaser Control server. That's going to start up a little module which simulates a person pressing the button. That would initiate a second call to a SIP server in Germany, which is calling this iPad over here. So what I'm going to do now is I'm going to call that number just normal on the telephone. What happened now is that the iPad is ringing. There it is.
Yeah.
Okay. If you press the button.
Hello.
Yeah, perfectly.
Hello. How are you?
Hello.
Who is that?
So we have now communication going from here 7,000 miles that direction, going to through a server, going up another 1,000 miles to Germany, and coming back to 7,000 to that iPad over here. So well, I think it's something not usual. Okay, the second demo I want to show you is actually similar to the one that we did yesterday at the lightning talks. Let me give you, yeah, I'm going to do that. I think that should be connecting. Okay, now this is the visualization of our house in Spain. So you see the 3D graphics in the background. What I'm going to do now is I'm going to go into the lower floor. I'm just going to turn on a little light at the wall because we got a nice little fish tank over here. And our fish, I get some really bad words from my wife and his brother that I was scaring the fish last night because I turned on the lights. So actually, okay, yes, okay. Can you put on the gray blacks to 25%, please?
Wait a sec. Okay.
actually turn off the lights at the aquarium down here. I hope. Yeah, there they are. Okay, so we're controlling the lights here from this side of the globe on the other side of the planet, basically. Okay, one of the things I wanted to show you also is, for example, up here in our office, this is our gadget for climate control, where you can control the fan coils, the temperatures, the heating, what kind of mode you have. Downstairs, we got different kind of gadgets. For example, for the timer, that's the time that officially the aquarium lights are on or off. Let's see what else. This is the dimming gadget. That's the light that Max turned on to 25%. You can increase it or decrease a little bit so our poor fishes don't get really that scared. Okay. Well, and got the media control, everything that we want to have in the system. The values get recorded, door communication. If somebody rings the bell at our house, we record the image of the person that's standing in front of us. So every time UPS comes and says, well, we couldn't deliver the package because nobody was there, and I look up in the directory and I don't see this frustrated UPS guy pushing the button, I know that, well, he was telling me some kind of fairy tale. So it's fun and it's really nice to use. Okay, where are we now? Okay. So Phaser control, we started development in 2006, and we started doing projects in 2008, or well, it is a product since 2008. Up until now, we got more than 40 projects with it, and the smallest ones are just apartments with 50, 60 square meters. Well, going over some really nice houses, villas, and some crazy stuff in there. One of the things is, for one customer, what we did is a little security system that you have to type in a key number, and if you typed in the correct key number, then the floor of the swimming pool would lower itself. So usually the swimming pool only is like 25, 30 centimeters deep, so it's not dangerous for the children. But if the grown-ups are going to go up there, they just type in the code, the floor lowers itself, and then they can really go swimming. And I mean, such things is quite simple to implement in Phaser control. I mean, of course, you need a swimming pool where you can lower the floor. And we've seen in the past couple of years some crazy stuff, you know, like houses that don't have an elevator, but they have the mountain train going up on the side and stuff like that. The biggest project we're working on is in Switzerland for the region Thurgau, where we do energy measurement in a total of 130 public buildings. Oh.
It is raining. Someone is going home. Ask your wife. I don't know why.
Well, it's not going to be UPS.
Why are you scaring the fishes?
Some problem.
Somebody breaking in.
Well,
They're just trying to keep you on there.
yeah. Okay. So, I might get into trouble later on. Okay, so so those are kind of nicer projects. I mean, from the 130, we're a little bit, well, we're not there yet. We have done about 30 buildings, and they're just collecting all the energy data and pushing it to one server where they do write that into spreadsheets and everything. Another nice project we did in Palma, some art galleries. Those art galleries are all linked together, and they have synchronized RGB lighting in the windows. So if you go down the street, you see the changing colors, and you see all of the 3 stores, and they're doing everything in sync, and that's quite interesting. Okay, next. This is sort of like the marketing part. I'm going to go up to technology in just a second. Right now we have more than 20 different kind of protocols in Phaser control. Protocols, systems that we can integrate. Popular one in Europe is KNX, which is for high-end buildings, or middle little level buildings. It's very popular. And so there are 700 companies making products for that. And you can come from a very simple plastic light switch like here to really high-end systems in glass, metal, or anything. And so that's a really nice system. DMX for lighting as well, that's something that comes from the theater branch. Digitalstrom also, that's very popular in Switzerland especially. It's a system that you can install afterwards once a house is already well wired. It's just a power line system. We can integrate white goods like Miele at Home and Surf at Home. There are a couple others that would be really simple to integrate, but we haven't had a chance to work with those components yet. For the multimedia part, well, the most important one is UPnP because a lot of music device companies support that, Squeeze, Greenbox, Revox, Denon. There are some more that are not on the list. I talked about Creston with you before. It's sort of like in a prototype phase because well, we hadn't had the chance yet to really have access to a Crestron system. And there are some others. Well, and then of course the whole network part with sending off, well, for example, reading and sending SNMP messages. So for example, it's no problem to put into your visualization also the status of printers or whatever in the system, sending off emails. So for example, one of those little spin-offs that we have is a little box with an Arduino processor and some just some environment sensors for temperature, humidity, and the only thing it does is send off an HTTP message to a server where the data is recorded and saved. And then you can get all the data in spreadsheets. You can send off alarms if the humidity gets too high, so you have a risk of mold in your house. That's pretty convenient. Well, that's about it from the protocol side. Okay, next. So, who are the companies using phaser control? We have a couple of companies in Spain, in Mallorca. We are doing ourselves projects in Mallorca where we well, make the plans, decide what components should be installed, how the whole thing is going to work. But our major goal is to have other electronics consultants, planning companies, architects using phaser control to make that high-level integration. So our biggest market actually is in Switzerland, region of Zurich, where we have a couple of well, big companies like Siemens, EKZ, which is the energy company in Zurich. And they're using phaser control in all of their consulting and high-end projects. And also, I bring consulting in Canada. And, well, okay, next page. So, actually, there's no real competitor for us on the market. There are a couple of systems, but they usually concentrate on one or two protocols. They usually have some sort of like a scripting language or something where you can also access third-party components, but it's usually, it's like a hack. And it's not really thought through. They don't have a real good architecture. So, well, the thing is, for us, it was very simple, or is very simple, easy to make a three-tier architecture in Smalltalk. Well, from our background, what we had before phaser control were the frameworks phaser. You notice the similarity in the name. And well, with the phaser frameworks we were using in large-scale applications at banks, insurances, and where you just work in 3 tiers. And so actually phaser control resulted from an idea in 2006 where we were remodeling our kitchen that we, well, we had to integrate the stuff we had. We have sort of like a little competition with our neighbor who has the better kitchen, who has the nicer kitchen. He is more into design. He is more into design. We are more into technology. So we had the the controllable light switches, the white goods and everything, and then we thought, okay, now what I want to do is, when I turn on the hob, I want to have the lights come on. When I open up the dishwasher, I want to have the ceiling lights come on and point on there. And you get all of this information in different kind of applications, but you can't integrate it into one. So what we did is used our frameworks and tried to integrate the whole thing, and well, it worked. And we showed it to friends, and they said, okay, I want to have that, can you do it as in my house? And so this was sort of like the starting point of Phaser control at that point. So for the 3-tier application architecture, which is actually ported from a, from a banking application, if on the lowest tier you have the service level where we have the connection to the actual subsystem behind. And then in the middle we have an object model where we interact with all of those services from here. And then we have the presentation layer where we generate HTML5 code that can be presented onto different kind of devices and for the user to interact. So on the lower side here, on this side we have the platform dependent data types where we really have the IP packets the way each system needs them. And on this side we have compatible data types, so that each one of them can talk with each other. So in this case, I can take, for example, from a Sonos multi-room system, the title that's currently played on the music, and send it off to the KNX system, where we have really nice panels for the wall and display the title that the music is playing. So if I push a button then on the KNX, I send off an action over to the Sonos to stop the system or play the next song or whatever. So this is really easy for me to integrate the whole system. And then of course the presentation layer only accesses the object model. And in the presentation layer, I'm saying, okay, I got a switched light or a dimmable light, and I want to have it on the web page at this location. And if I click on it, I'm going to have this pop up. But at that point, it doesn't interest me if it's working with KNX, AMX, if it's connected to the serial port or whatever. Presentation layer only concentrates on displaying objects of the same type in the same manner. Okay, let's do the next page. Okay, another concept that's really, easy to do in Smalltalk is we have a facade concept from the editor to the server. Phaser control is actually two applications. One is the server application. It's a headless application, runs on the server 24/7. And it's just a black box that's running there. It's a Windows service, and you can use all of those standard Windows mechanisms to start, stop, monitor it. And the other one is the editor, which is a GUI application you put also on, just on your PC. And this editor connects to the server in the background. And the way they communicate each other, the object is on the server, has an object ID. On the editor, I have a facade, which knows the object ID of the object it is representing. Does not understand the subclass, so if it gets a message, gets sent off to the server, does something, comes back, and you see the result. So, and using this model, you can do anything in the server. And that's actually pretty neat. Okay, next page. The advantage 3 is because everything is an object in Smalltalk, modeling the real world is really easy. So if you look into basically all of those systems, they have some kind of way to communicate within their own devices. Usually they have an own radio protocol, they have an own wired protocol, they have whatever. And then you have some kind of gateway that translates the system components to the IP side. So what we're doing in Phaser control is we model exactly the same thing. We're talking about a connection, which is in this case this gateway over here, and we got elements down here which are connected to this connection itself. So for example, let's take the Sonos system. Well, the Sonos system, there, okay, well, it's a bad example because there's actually no gateway because everybody is a gateway there. But, well, your gateway is the UPnP interface actually, and the device is all the different players that are located in your house. But let's take, for example, the white goods implementation. They communicate over power line. There's a power line modem, which translates IP to the power line level, and then communicates with the dishwasher, hob, whatever. Okay, so, yeah, let's go to the next page. Advantage number 4 for me is working in the debugger. It's
not only for you.
I would say the debugger is, for me, it's the most important development tool. Usually what I do is we just build up base classes using the normal editors. We define the methods that are in there, put in breakpoints, and then we just develop the methods on and on as they are being used. And well, you can't do that in another programming language. Okay. Yep. So another advantage that also the well, our competitors, well, not really competitors, I mean, the other home automation systems, what they can't do is, this is now a screenshot of the Phaser Control editor. This is what a user of Phaser Control sees when he is working with the system. So we have building blocks in here. We got attributes down here. We got events here. This is sort of like the output side. This is the input side on this side. We got attributes as well, and we got different kind of actions. And what you do with those lines, you just connect attributes, or you connect events to actions. It's basically the visual H model. And so you just take your building blocks, put them in here, connect the whole thing, and it's working. And it's working live. You can test it right away. So there's no saving, compiling, loading it up to some kind of server, restarting the server, and continuing with your work. Like I said, for our competitors, this cycle of restarting their server and getting new versions in there takes like 5 to 10 minutes until everything is running again. So what the people using that system, what they end up doing is they're going to make like 10, 15 changes at a time. And what happens is, of those 10 or 15 changes, 5 are good, 10 are bad. So they reiterate all the time. And most of the time that they're spending is waiting for the system to boot. And so with Phaser Control, it's like open heart surgery. You build a new building block, you can control it with your lights, you see what's going to happen, and well, off you go. Next.
Is that the main language of your domain? What you present is a domain language in some ways.
It's a domain language.
Yeah.
Okay. Well, other key facts. For the technology part, in Smalltalk, you have a whole lot of frameworks you can use. We use clearly our own frameworks, but we also use third-party frameworks, system frameworks. There's so much stuff out there. It's only problem is you have to find it. And there's so much things out there that, well, usually for all of the problems that there are, you can find something. The other thing from the technology point of view are patterns. And every developer has his patterns on how to do something. It doesn't necessarily mean that you have to use official set of patterns. You can just, everybody does that, what he knows best. And well, also for us, I have 25 years experience now in Smalltalk. With all the people in the company, we average around 50, 55 years of Smalltalk. So there's some really know-how, serious know-how in there. The other thing that's, well, for VA Smalltalk again, it's the stability. It's really hard crashes. Yes, there are a couple ways. Usually DLLs are involved, but something unexpected in the system usually never happens. There are no memory leaks or anything. It's really, or if there's a memory leak, it's from us that we didn't program correctly. Well, the other thing is performance. We have the, what we do is we have a little computer. We call it the Phaser Control Mini. It's actually a 386 processor. Runs Windows XP embedded on 750 megahertz. Has 2 gig of RAM. And 256 megabyte of RAM and 2 gig of hard disk. Runs Windows XP embedded. And Phaser Control runs perfectly on that system. And the system has enough performance for a normal one family house. Well, then overall, what's important for us, it's fun to work with. Okay, this is part again from the know-how and the experience. We can concentrate on the job, what we want to do, and don't have to hassle with too many system constraints, too many, problems that are on the way with normal programming languages. Okay, but the major thing actually is, we just go to the next page. Okay, why Smalltalk? Well, for us, it's simply the best platform available. Actually, at that point, I wanted us to put in a page in there with some words from Leonardo da Vinci, who said that simplicity is the ultimate sophistication, but I just thought that this might be counterproductive. Okay, very well. So I think that was one of those talks that are more than in time. Few.
Do you have a security model on the controls that have been configured on the system to prevent children or energetic adults from changing them?
Actually, we do. It's part of the presentation layer. Okay, the system is controlled by user ID password. So if you, per default, we have 3 levels, well actually 4 levels of security, which is public. That's the only thing you're allowed to do when you're a member of public is see the login screen. Then we have guests, users, and administrators. And for each level, you can define which objects you're allowed to manipulate and which objects you're allowed to see. You can define your own security levels, and you can manage the system any way you want. Then the other thing is, in Phaser Control itself, we have our own namespace concept. So for example, it's rather the issue that you have elderly or children using the system. Usually children know the system better than you do. I mean, you saw my son here. He is just working on the system every day, actually. Well, using the system every day. But the problem is, for example, if you have an apartment house and you have 5 different apartments, for one thing, you have shared resources, like the video camera from the entrance, the weather station on the roof, the satellite dish on the roof, and satellite system. But each apartment has its own lighting and his own access control and his own shades and everything. So what you want to have is that each apartment can use the public stuff plus the local stuff. And, but you're not allowed to use from one apartment the things from the other apartment. And so with the namespaces, they are hierarchically organized. So you get the top namespace would be the public one, where you have the weather station, everything in there. And then you would have 2 namespaces below it. You get the things from the one above, you get inherited. And you have your own things. And through the authorization model, when you're in the web page, even if you hack the web page, with your authorization code, you can only work with objects in your namespace or the ones that you inherit. So even if you know the name of an element of another apartment, well, you can access it, but the system would say you can't send a message to it. Or for example, in the application I told you about Turgau, the buildings are organized, well, there's whole Turgau, then you have a town, then you have, well, the functionality they have, and then within that you have the official building. Because the janitor, for example, for the schools is only allowed to view the data for those schools, but he isn't allowed, for example, if the police station is next door, what kind of level their oil supply has. That's only allowed, again, on the next level up. So that was also quite a hassle with them, with all of the security models.
So how scalable is this within a control module?
I want to give you another reference. The base architecture, I told you about, we were using our old our frameworks, our active frameworks where we built applications. The biggest of the core frameworks that do transaction and the object manipulation and everything, our biggest application is for Deutsche Bank, and they're doing marketing of life insurances with that system. And they have 7 servers in Eschborn, that's near Frankfurt, and they're doing about 4 million object transactions every day on that. They're selling, well, they're making offers for about around 10,000 life insurances every day over Germany. And so it's quite scalable.
So you're saying you have this reuse from the life insurance to the home automation?
Yeah.
All right.
And I mean, it's the Mini. It's a processor with I think it's 786 megahertz what it has. If you look into the task manager, the processor never gets more than the phaser control task never uses more than like 10 or 15% of CPU time. So it's, I'd say. Yeah, I mean, what's happening here? I mean, you're not turning on a light 100 times a second. Yeah.
It's not a disco.
Not a disco. I mean, we can get the performance up if you have complex light scenes and sequencers things where you have like every 100 milliseconds a change of, I don't know, 20 RGB channels, the lighting level. But still then you can get it up to like 40, 45%, that's it. One of the things we have in there is integration with eKey, which is a fingerprint reader software. And it's, so for access control, if you have the fingerprint reader active and you pull your finger through, then they have, well, that sub-module, it's a DLL, they do quite some calculations. That gets up your processor usage. So it's detecting your fingerprint in like 300, 400 milliseconds, and you have to really get the 100% peak at that time. But that's worst case scenario.
But it's not a separate box, so it does the computation.
There's a software in there.
Yeah, but it's done in the same computer?
Yeah.
Because usually that way you have separate modules and you connect, so you have no problem.
It's
like in the factory floor, you never do the computation there, but you have modules that are
yeah, I mean, it's in, let's say, for the fingerprint access, usually have like 2 or 3 doors at the maximum. And usually they have also the door opener itself on the visualization. So it's not a security issue because you have other ways to get in as well. If that would be now, we have one customer, well, I hope we're going to get that. It's going to be a hospital, and they're going to work also with, well, biological samples and everything, so they need to have a really high security level. In that case, we're going to just put that in a separate box from them. I want to interface it. I want to have events from them.
Controlling
they're just going to push their data and their events to me, but well, we're not going to make the security on that level. And that's a nice thing, actually. I mean, we have all the possibilities to, you know, fulfill the demands of each customer.
Is there any national or local regulatory requirements that you have to meet for this kind of a system?
Fortunately, that's in the responsibility of all the subsystems. So if you use, for example, KNX, they have worldwide certification, or well, in most countries, I don't know if some remote country not, but in the Western world, you can use it anywhere you want to. Also, if you go into audio systems, well, they have to comply. The hardware from them has to comply with the regulations. From us, we have only the Mini, and that has a 24-volt interface. And well, the wall, the power source, power supplies, that has to be certified, but the rest is not a problem for us.
This is fascinating stuff.
Yeah, and it's really fun. I mean, it's you know, it's sitting in your application, turning on some lights, and playing around with temperatures, and it's really neat.
So is it useful? I mean, it's neat, but why would I want to change my lights from 7,000 miles away?
Well, it's
I know the answer to that.
okay.
A friend of mine built his cabinet up north with a lot of the automation stuff, and he has a single system, so he has to have all the controls. He's limited to what he can get with that system. But what he will do when he's getting ready to leave the valley, when he gets up to about halfway, he'll call his house and he'll turn on the heater, and he'll turn on. He'll send a notice to a security company that he's coming up, and it's all going through his router. So for a second home in particular, it lets you, do these controls that are very convenient for you when you get there.
Well, it's, for example, if you're leaving your house, you have one button you push. Okay, with that push of that one button, all the lights are off, all the shades go down, all the electrical outlets turn off. So you have no more the question, did I turn off the iron? Did I turn off the oven? The music is off, the alarm system is active, and you can just leave. I mean, when I was a kid, I don't know, I drove away with my parents, visiting my grandparents. I think every second time we turned around. Yeah, that's okay. Every second time, about 10 kilometers off, we turned around because my mom said, "Are you sure you turned off the iron?" So, and that's the thing, you can't just, this is, it's,
So there's so many
you could
things
just
you
say
can do,
that
some
that's
of them
not-
are more useful than others, probably.
Then, for example, we have motion detectors around our house. So if motion is detected on the outside, first of all, the lights come on in the office, then 5 seconds later in the stairway, then 5 seconds later in the
someone
lower
is going down.
as somebody is coming down. It would be really simple to, in that case, in that scenario, to play a MP3 file with dog barking.
Is there a way to set up scripts so that you can say, while I'm away, every day at 8 a.m. turn on the lights for 2 hours, and then.
Yeah, but that would be very static because, if you have a bad guy, he's standing there with his watch and he says,
Yeah.
8 o'clock, okay, he's away today. So what we actually normally do is we record for 1 week the lights, how they go on and off during the night in the house.
Okay.
And that file we replay every week. So, I mean, you have people in the night going to the bathroom, you have music playing in the living room, and so it's a lot more vivid. You turn on the pool lighting, and immediately the whole thing looks more alive. So you can really, I don't know, you can, a really professional that wants to get into your house because he knows that you have that $1 million coin collection in the cellar, he's going to get in. But for those who are just looking for an opportunity, you're going to scare off with it.
So when does your house become self-aware and lock you out?
Yeah. That's actually a possibility. But it's, well, you can always hack into the system. Well, the thing is, what we're also doing is, when we design the automation for a house, we are talking about 3 levels. We have the security level, which means those are systems that have to function whatever happens. So in every room is one light that's working. If you have an outage of power, if the bus system is not working, if the server crashed, everything, you have this one light working. It's not pretty, it's not really for the longer times, but it's just your security. On this level, the doors don't have to be locked. You always have to get out somehow. If the house is burning, your server is crashed, you don't want to be locked in. The next level is the normal level, that you can have a light switch and you press it and your light comes on. That you have at least, you don't need all the light sources, but at least 1, 2, 3 lights in a room you have to have working. And then the third level is the comfort level, where you have the light scenes, yeah, that you say, for example, we had a house where they had 65 individual lights in the ceiling, all controllable by a dimmer. So if you would do that conventionally, you would have dimmers like this. And you would need a matrix like, C4 is the light over the table or something. In that case, we reduced all of that to 6 push buttons, which are light scenes, which is night light, cooking, eating, watching TV, reading, and cleaning mode when the cleaning lady is coming. So those 6 switches are in there, and that's all they need. And you adjust the lights levels of all those lights that when they're eating, that you have all the lights on the table, and the rest is a little bit dim. When you're with friends sitting around it, sitting on the couch, then you want to have a different lighting and just use it to the appropriate scenes.
Is it correct to say that for a full installation of home automation, that the control system is a relatively small part of the cost?
It depends. It really depends. It depends on what you want to do. It depends on what kind of system you're using. And the interesting thing with our technology is that it can grow in the future. You're not limited. You don't have to say, okay, I have to pick a system now where you can control lights and music, and I don't know, maybe I want to have TV in the future, and what about the heating, what about my air conditioning? Oh, I can only use those in those models. Because we are open for the protocols, you have a lot more variants that you can do.
Well, when my friend told me about his cabin and his installation, it sounded like the individual control components, what you were controlling, were relatively expensive compared to what he had for the software to control it. It
gets, well, if you do a per component price, it gets cheaper the more you do.
Oh, right, yeah.
Because you have this big investment in the beginning where you have to have a server and a certain basic infrastructure, and that goes, well, if you, they're like, 25 channel dimmers, and the per channel is, gets down from the price. I just get the message that I have to finish.
Thank you.
Yeah, if you have more questions, I'm going to be outside, and well, thanks for your attention.